All right. Hello again, Leilani, Jason, and Richard. So I think we're recording now. Welcome to Linear Algebra on this Saturday evening. So first off, sorry I wasn't able to schedule another meeting last week. Wednesday was a holiday, which was usually our day. But since Wednesday until kaninang umaga, I was in a conference for higher education in Alabang. So medyo kakauwi ko lang din. So I really wasn't able to squeeze it in. And I know that you have TTH sessions for abstract algebra. But anyway, here we are. We'll continue on with our discussion. Just some reminders. I think homework number 2 will be due when? Due na nga ba tomorrow or no? Let me double check. Do you guys remember
Monday
when?
po at
Monday pa. All right, good. So, but again, if you are not yet done with the homework, then do the best you can. The Monday deadline is just for getting the premium, the 10% premium dun sa score. But if you feel if you will get more points, if you will work on it a couple more hours or one more day, then that's fine. Submit it whenever you can. Ang deadliest deadline lang natin ay last day of classes, which is on July 29, I think. So, or 28. So, yun yung targetin natin. Ano? And also, I'll start grading the first two homeworks tomorrow, so you will start seeing grades. Although may problema pala ako sa Moodle kasi pag nag-check ako doon kailangan ko pang i-download sa tablet ko. Hindi katulad sa ginagamit kasi namin sa UPLB Canvas na I can check your PDF right on the app. So hindi ko siya kailangang i-download at i-upload later. At least yun yung experience ko sa Moodle 2 years ago when I handled this course. So yeah. Titingnan ko na lang. Pero hopefully hindi ko siya kailangang i-download kasi if that will take a couple more minutes to do. Tapos usually ginagawa ko, dina-download ko muna lahat ng problem 1. Tapos checkan ko muna lahat ng problem 1. Then isa-isa ko silang i-upload para makita niyo yung feedback ko. So if that's the case, then probably over the weekend, you'll see some progress in the grading. But yeah. And then I'll start writing up the answer keys and I'll provide you with password protected copies by Monday siguro. All right, so I hope that's okay. And where were we? It was a week ago. We're still in module number 1, and I think we finished the compact criterion last time. Tama nga ba? We stopped at theorem number 3. And this gives us a nice way of checking whether a subset of a vector space is a subspace, right? So there are now new terms in your vocabulary. So remember, we started with fields, which is basically an abstract mathematical structure consisting of a set together with two binary operations on the set, right? So you have f together with addition and some sort of multiplication, satisfying several properties. And these properties are akin to what we know for the real numbers. Kaya lang sa linear algebra, hindi talaga field yung gusto nating pag-aralan. Yan yung para sa abstract algebra. What we really want to look at are vector spaces, because vector spaces, these are the collection of objects that occurs in practical applications like in electrical engineering, in physics, etc. So they use vectors in those subjects, and vectors can be studied as objects in a physical application, or it could be the beat of the show, right? So it could be the hero of the show, wherein we look at the structure of vector spaces. Now, the end goal of this course is to learn about the properties of functions that has some sort of a linearity property, hence the term linear algebra, that maps a vector space to another vector space. So I hope now we have an idea of what a vector space is, right? So the vector space is a collection of objects we call a vector, together with some sort of vector addition and scalar multiplication, all right? Where the scalar multiplication are operation between a vector and a member of the field. So ngayon, pwede na nating tawaging vectors, yung mga elements ng vector space, Tapos scalars, yung element ng mga fields na nagsiserve as scalar multipliers. Alright? Kasi sa vector space, dalawa yung set natin. Meron tayong set of vectors na bumubuo ng vector space at meron tayong field kung saan nanggagaling yung mga pang-scalar multiplication natin. Alright? And then usually we don't want, or in some cases, we don't want to study the entire vector space. We want vector spaces because they possess nice properties, yung nasa definition number 2. Pero usually, hindi natin pinag-aaralan yung kabuuan ng vector space. What we usually study are subspaces, which are a tiny fraction or just a portion of the actual whole vector space. Pero ang kagandahan sa subspaces ay vector space din siya on its own. All right. So it's really a subset that is also a vector space. And we look at several examples of vector spaces last time, and we culminated with theorem number 3, which tells us a nice way, an easy way of checking kung subspace ba ang isang subset ng isang vector space. So sabi natin, instead of checking all the properties of a vector space na nandun sa definition 2, kung nag-apply siya dun sa subset, dalawang bagay na lamang yung kailangan nating tingnan. We need to check whether the vector addition and scalar multiplication are closed. If the subset is closed under vector addition and scalar multiplication. So, ang gagawin natin para magamit yung compact criterion, pang-check kung sila ay kung ang isang subset ay isang subspace ng vector space, kumuha ka ng dalawang element or dalawang elements nung subset. Alright? Nung subset. Tapos, tingnan mo, kapag pinag-add mo yung dalawang arbitrary members ng subset na yon, element pa rin ba siya nung subset? So that is closure of vector addition. That's the closure of W, of curly W, the subset under vector addition. And then the next thing you need to check ay closed ba yung subset with respect to scalar multiplication. Pag nag-multiply ka ba ng random scalar dun sa yung random vector, ang sagot ay nandun pa rin sa W. Pag na-satisfy yung dalawang cases na yon, closure under addition and scalar multiplication, then you get yourself a subspace. Okay, is that good? So I think that's where we are right now. Any questions about those topics? Okay, mukhang wala naman. And I see many of you are submitting homework problems na. Dumadagsa na nga siya sa email ko. So, yeah. Okay. So, as I've mentioned, hindi lahat ng vectors gusto natin pag-aralan. Most of them are subspaces. But looking forward, hopefully to the next half of this session, ay yung isa pang klase ng mas maliit na set ng vector space na gusto natin pag-aralan. Una, subspaces, pero minsan, mas magandang pag-aralan yung tinatawag natin na basis para sa isang vector space. So, Module 3 talks about basis for vector spaces. I just uploaded the second module kanina, and I guess I want you to finish reading the module, and then we'll have some discussions about it anyway by this week in preparation for homework number 3. All right? Medyo bibilis na yung pacing natin ngayon kasi pinakamahaba talaga yung module 1 kasi siya yung pinakabago probably, and this is setting you up for the theoretical things that we'll be doing for the rest of the course. So I think we spent 2.5 weeks for module number 1, but for module number 2, medyo mas mabilis. 1 week lang yung feeling ko ay kakailanganin natin para sa module na yan. All right? So those are 2 things that we want to do today. Still look at examples of subspaces, and then next, look at what bases are, or start talking about bases for vector spaces. Okay? Now, can anyone give me 2 quick examples ng isang subspace? Hindi ko alam kung natanong ko na to last time. Di ba, kailangan mo lang vector space, kukuha ka ng isang subset niya na vector space pa rin. Can you guys think of easy examples of subspaces? Sige nga. Plus magbibigay ako ng +1 sa homework or ideas. Kung meron akong vector space V, can you give me the two easiest, though subjective yung easiest, no? But I think it's universal. The two easiest examples of subspaces of that vector space.
Sir,
Yeah, Richard.
pwede ba yung um, nasa isip ko yung eigenvectors or the basis.
Uh-huh.
Uh, uh,
Well, mukhang hindi sila yung pinakamadali. Though subjective nga yung pinakamadali. But nice try, Richard.
Thank you, sir.
Yeah. Jason.
Sir, try lang, sir. Pwede ba yung zero vector po?
Zero vector. Oh, kasi, so your suggestion ni Jason ay saan ako pwede magsulat? Dito na lang. Set containing the zero vector. Usually, tawagin natin zero vector. The set containing the zero vector, yes, it is a subset of V. Alright? Kasi nasa loob ni V yung zero vector, hindi siya magiging vector kung wala sa kanya yung zero vector. Oh, by the way, when we say the zero vector, siya yung additive identity under vector addition, right? Ito yung pag inad mo sa kahit na anong vector, yung inad mo na vector, siya yung sagot. Alright? Tapos gagamitin ko yung compact criterion. Kailangan kong ipakita na kapag ka nag-add ako ng dalawang elements nung candidate ni Jason, dapat nandun pa rin sa set na yon. Ang curly W dito na binigay ni Jason ay the set containing the zero vector. Alright? Ang kagandahan, isa lang naman yung laman nung set na binigay ni Jason. So pag nag-addition ako, isa lang yung posibleng addition problem na meron kay curly W. Yung zero vector plus zero vector at ito ay equal kay zero vector na kay W din. So we say that W, the set containing the zero vector is closed under vector addition. And then pag kumuha ko ng isang scalar, minultiply ko siya sa zero vector, ano yung sa proposition 2, meron dong nagsasabi ng any scalar times the zero vector ay equal din kay zero vector. Eh si zero vector na kay W, siya yung katangi-tanging laman ni vector W. And so the subset W Jason gave us is also closed under scalar multiplication. And therefore, by theorem number 3 or by the compact criterion, we can say that the set containing the zero vector is a subspace of any vector space. So pag hiningan ko kayo ng example sa compre, hiningan ko kayo ng example ng subspace ng kahit anong vector space, isa sa mga pinakamadaling sagot ay yung set containing the zero vector. All right? Okay, and that gives Jason +1 sa homework. Ano na lang ako, paki-remind na lang ako, Jason. Sana hindi ko makalimutan. Yeah.
Thank you, sir.
All right, so yeah, let's give you a +1 sa isa sa mga items na na lang siya ilalagay. Si Richard, nakita ko kanina, nakataas ng kamay. Maybe you want to give it another go, Richard? May isa pa kasi. Or anything. Ayan, Richard.
Another try, sir. Unit vector.
Unit vector. Yeah, hindi closed ang mga unit vectors. Kasi pag nag-add ka ng dalawang unit vectors, posible na ang sagot ay vector na 2 times the unit na yung size. So, yeah, hindi siya closed under vector addition. Nice try though. I'm seeing Sol. Sol, hi.
Sir, yung set itself, yung space itself.
Okay, great. Usually nakakalimutan natin, no, yung set itself. Good. Si V ay subset niya. So si W, pwede niyong kunin to be a V itself. And it is still a subset of V. And then of course, alam mo vector space si V. So si W being equal to V ay vector space din. So the vector space itself is a subspace of itself. So Sol gets the other one bonus points. So, okay pala pagka may no, pag may pa-bonus, talaga nagsasagot kayo. So, yeah. So those are the quick examples of vector spaces. The set containing the zero vector is what we call the trivial the trivial subspace, and the set itself is an improper, or is the I want to call it an improper subset kasi usually yung trivial subset ay improper din. So pag sinabi ko na proper subset, so halimbawa sa compre, sinabi ko ay give me an example of a proper subset, or sorry, a proper subspace of this vector space, then dapat hindi siya trivial subspace at hindi rin siya improper subspace. All right? So hindi siya dapat yung set na iisa yung laman, which is the zero vector, at hindi rin siya yung vector itself. So yeah, that gives us three classifications for subspaces. The trivial subspace, which is the set containing the zero vector alone. The improper subset, or yeah, the improper subspace, which is the set itself, the vector space itself. And third are the proper subspaces, which are all the other subspaces. Okay? Now, those are quick examples, but let's look at some ways of constructing subspaces for a vector space. So proposition number 4 gives us another way of getting subspaces if you have a collection of subspaces right away. So again, we start with a vector space, tapos kukuha ako ng mga subspaces niya. Si W1, si W2, si W3, W4, W5. Kunwari lahat sila ay mga subspaces. So that's this family you have over here. Whenever I write 1, n overline, pag may overline yung 1, n, ibig sabihin nito ay 1, 2, 3, 4 hanggang kay n. So yun yung ibig sabihin na naka-overline. So si W1 hanggang si Wn ay mga subspaces ni V. Tapos, kung gusto mo makabuo ng isa pang subspace, kailangan mo lang daw gawin, kunin yung intersection ng mga subspaces na yun. Alright? So, in Venn diagrams, if you're gonna draw that, so meron kang V, tas nandito yung improper subset, yung halimbawa itong dot, ito yung trivial subspace, which is just the zero vector. Tapos halimbawa si W1 ay ito. Siyempre, dapat laman ni W1 yung zero vector. Si W2 halimbawa yan. Tapos si W3 halimbawa ito. Okay. Tapos si W4 ay ito. W4. Pag kinuha mo yung intersection o yung mga common elements nitong 4, 5, or 6 na vector spaces na meron ako rito, na subspaces na meron ako dito, si W1, si W2, W3, W4, trivial subspace, at saka yung improper subspace, pag kinuha natin yung intersection nila, which could be, masyadong malaki yung pang-drawing ko, itong intersection nila, yung set of all common elements present in all of those 6 subspaces, subspace pa rin daw siya. Right? So the intersection of subspaces ay subspace pa rin. Okay? Is that clear? Clear yung sinasabi ng proposition 4? So I hope it is. Syempre, hindi natin yan tatanggapin on its face value. Let's look at a proof of proposition number 4. Hold on. Ano muna ako ng kape? Sarap ng kape. Hopefully, anyway, so let's take a look at the proof. Well, again, proposition number 4 is claiming na etong curly W, right? Si curly W, siya yung intersection ng lahat ng mga W sub i's. Lahat ng W sub i's ay mga vector spaces. Mga subspaces ng vector space V. So in expanded form, this guy is just curly W1, intersection curly W2, intersection W3, intersection W4, hanggang makarating ka kay W5, Wn, right? So pag in-intersect natin yung mga subspaces, ang claim ni proposition 4, subspace din yon. Now, whenever you want to prove that a certain set is a subspace, ang pinakamadaling paraan, most of the times, is to use the compact criterion. Okay? Yun yung gagamitin ko para ma-prove yung proposition number 4. Compact criterion, that's theorem number 3. Alright? So as we did earlier when we are checking Jason's example kanina, ang ginawa natin ay kumuha ako ng dalawang random elements ni W. Kasi si W, gusto ko siyang ipakita na siya ay subspace. Para magamit si compact criterion, kumuha kayo ng dalawang arbitrary elements nung gusto mong ipakita to be a subspace. That's why I took V and W from curly W. Pero ano nga ba si curly W? Si curly W siya yung intersection ng lahat ng mga W sa bias. Common elements ng lahat ng W sa bias. Eh si V at saka si W ay na kay curly W. So ibig sabihin lang nun, si V at saka si W ay nasa lahat ng W sa bias. Agree? Agree ba? Kinakabahan ako, tahimik nyo. So I hope that's clear. Nasa intersection si V at saka si W. So si V at saka si W ay nagbibilong sa lahat ng W sabay. Okay? Pero anong alam natin dun sa mga W sabays? Silang lahat ay mga vector spaces. Kasi subspaces sila, right? We are assuming that the W sabays are all subspaces. Ngayon, gagawin ko na yung check. Ano yung dalawa kong gustong i-check? Gusto kong i-check kung si little v plus little w ay nakay curly w ba? At yung alpha v ay nakay w rin. Pag na-prove natin, napakita natin na totoo yung dalawa na yan, then we can say that by compact criterion, subspace siya. Okay? Now, pag tinignan ko yung v at saka yung w, pag pinag-add ko sila, yung sagot ay dapat nandun din sa lahat ng mga W sa bias. Kasi nga subspace yung mga W sa bias. Lahat ng W sa bias ay mga subspaces. Si V at saka si W nasa lahat ng mga subspaces. Eh dahil subspace, yung mga W sa bias, pag nag-add ako ng dalawang laman ng W sub I, nandun pa rin siya kay W sub I. Kasi nga, vector space si W sub I. So that means V plus W is an element of W sub I sa lahat ng I. Alright? Si V at si W nasa lahat ng W sub I's, lahat ng W sub I's ay vector spaces. So pag inad ko si V at saka si W, dapat na kay W sub I pa rin siya dahil vector space nga yung W sub I sa lahat ng I from 1 to N. Dahil yung V plus W ay nasa lahat ng W sa bias, so yung V plus W nandun sa intersection ng lahat ng mga W sa bias, which is our curly W. And so this is now a check. Kalahati na ng compact criterion yung napakita natin. Good? The next question is, closed ba si W under scalar multiplication? So I will take an arbitrary scalar. I'll call it alpha. I-multiply ko siya sa V. Titingnan ko kung na kay W sabay din. Yes, siya. Pero similar argument naman yung gagamitin ko. Kasi si V, nasa lahat siya ng W sabays. At lahat ng W sabays ay vector spaces. So pag kumuha ko ng isang scalar, minultiply ko siya kay V, nandun pa rin siya kay W sub I. Kasi nga, closure of the vector space W sub I under scalar multiplication. At nangyayari to sa lahat ng I from 1 to N. So ibig sabihin si alpha V ay nasa lahat ng W sub I's by the mere fact that each of the W sub I's is a vector space. Right? Dahil si alpha V ay nasa lahat ng W sub I, si alpha V ay nasa intersection ng lahat ng W's, ng lahat ng W sub I's. Alright? And this is the second part of the compact criterion. And so by proposition number 3, we have shown that the intersection of subspaces of V is indeed another subspace. Right? Good? All right, so that's one way of generating a subspace. Now let's consider a more intricate way of constructing subspaces. Pasensya na uli, pinagsasabay ko yung kape at saka yung discussion. But anyway, susunod naman ay titingnan natin yung mga linear combinations. How do we form linear combinations of elements of a vector space? So, kailangan, una, magsimula ka sa isang set X na subset ng vector space V. Okay? So, pag meron kang V, kumuha ka ng kahit anong non-empty subset niya. Tawagin mong X. Si X hindi kailangan vector space. Kahit ano siya, kahit anong subset ni V. Alright? So, ang gusto ko ngayon tingnan, ano yung mga linear combination ng vectors kay X. Alright? So, we define a linear combination of members of capital X as this sum. Ang isang vector V ay tinatawag na linear combination ng mga elements ni X. Kapag ka si V, kaya kong isulat as scalar 1 times x1 plus scalar 2 times x2 plus until scalar n times xn where the x sabays are coming from capital X. So ibig sabihin kung si X mo, kung yung set X mo, kukuha ka ng ilang members ng set X. Tawagin mo silang X1, X2 at saka Xn. Tapos partneran mo bawat isang vector X1 hanggang Xn ng mga scalars. Tapos kunin mo yung sum. So this guy, the summation of alpha I times x sub I is a linear combination. So ito ay linear combination of some members of X. So madali lang, capital X. Madali lang kumuha ng linear combination. Pumili ka lang ng mga vectors, i-combine mo lang sila. So combine, i-add mo lang sila, pero lagyan mo ng weights, which are the scalar weights. So lahat ng posibleng, lahat ng mga vectors na kaya nating masulat in this way is a linear combination of vectors in X. Alright? Can you imagine that? Or maybe a quick example para ma-imagine nyo. So halimbawa, ang aking vector space ay R3. Tapos ang ating field ay real numbers. So I'm considering the set of vector space, the vector space R3 with scalars coming from the set of real numbers. Tapos halimbawa, ang set X ko ay, sino si set X? Vector 2, 0, 0, at saka si vector, who's the other vector? Sige, gawin kong 4, 0 to, say, 0. Bawa, yun yung dalawang members ni X. Can somebody give me a linear combination of members of X? Sige, +1 din sa homework ko. Siguro yeah. 2 people? Yan, bilis ng Richard. Go, Richard.
Example would be kung
Aside
kukuha
from
tayo,
those
sir.
members of X, Richard, sorry.
Yes, sir.
Aside from 2, 0, 0 and 0, 2, 0.
Linear combination. So, sir, kukuha ko ng isang element sa F, let's say 4. Alpha is equal to, hindi. Yeah, real numbers pala yung F. So,
Yeah.
sir, ano ba yung F? Yung alpha ba is constant number or
Scalar.
any? Scalar. Okay. So,
It could be any scalar. You can, yeah, you're on the right track. You can select alpha to be 4.
4,
Tapos,
yeah.
I guess, ita-times mo to,
Tapos, times natin, sir, sa first element ng X, 200 plus plus 4 times the second element, 020.
So we get what?
We get 800 plus.
No.
Sorry.
Okay.
Sorry.
Go.
Yung ano na, sir, final, sige.
Diniretso ko na kasi.
880, yes, sir.
Okay, good. Thank you, Richard. So you get what's your surname? Baka makalimutan.
Larida, sir. Larida. Larida.
Baka makalimutan ko mamaya pag re-record ka. Okay. Yes, Raf. Si Raf yung susunod. Another example.
Good evening, sir.
Good evening.
So for my alpha, sir, I choose 1. Pwede?
Uh-huh.
Sir. Then I have 1, then 200 plus 1020. That is equal to, I have 200 plus 020. So the answer is 220.
Okay, good. Thank you, Raf.
Thank you,
Kaya lang
sir.
napansin ko sa example nila parehas ay pinagparehas nila yung alpha 1 saka yung alpha 2. Yung alpha 1 ni Richard ay 4, ang alpha 2 niya ay 4. Kay Raf, ang alpha 1 niya ay 1 at ang alpha 2 niya ay 1 din. Which is fine, pero there is no requirement that those two alphas are equal to each other. So maybe I can give another example, say 5200, and then this guy I'll make it say 1/2, or actually it could even be -1/2 kasi si -1/2 naman ay nasa si -1/2 ay nasa what do you call this, si -1/2 ay nasa field R din, tama? So that could also serve as my alpha 2. So another linear combination would be 10 comma -1 comma 0, which is another linear combination of vectors in 200 and 020. Okay. Now, let's say is 10 is 1000 a linear combination of x? Anyone? Then maybe you can explain me why. Yan yung tanong. So balikan natin yung set x natin. Layo na pala. 200, 020. Si 1000 ba ay linear combination ng members ni X? I'll just wait for another hand, Richard. Pero tawagin kita later pag wala nang nag-volunteer. Anyone else? Yung mga wala pang points. Meron na rin si Sol eh. Yung mga wala pang bonus points. Sige. Sayang naman. Si 1000 ba ay linear combination din ba ng mga members ni X? Sino pa yung wala pang points? Si Ian nagtatry na. Go, Ian.
Good afternoon. Ay, good evening, sir. Sir, hindi ko po nasimulan kaso magta-try lang po ako.
I'll go. Yeah.
Sir, 5.
Uh-huh.
Yes, yes, yes. Yes po ba, sir?
Yes, it is a linear
5200
combination. Mhm. Plus what?
plus zeros times 020, sir.
Okay, great. Thank you, Ian. Yes, that's right. Pwedeng mag-zero kasi ang usapan lang natin sa linear combination ay dapat scalar, dapat element ng field, and zero is an element of the field of real numbers, so it can serve as the second component. It could serve as our alpha 2, right? Tapos ang alpha 1 ni Ian ay 5, that will give me 1000. So 1000 is indeed a linear combination of members of X. Similar question. How about say 111? Is it a linear combination of members of X? 111. Okay, I'll take note of you, Sol. Sino pa? Leilani. Yeah, go Leilani.
Hello, sir. Good evening po.
Hi. Yeah, good evening.
I guess, sir, hindi po siya linear combinations of members of X
That's right. Why?
because the linear combination of the members of X will be 200 and 020 and not the values inside the X.
Aha. Pero
200 and 020.
Mhm. So dapat mapakita ko siya na hindi siya pwedeng masulat na linear combination ng 200 at 020. So bakit si 111 hindi ko kayang isulat na may alpha 1 times 200 at alpha 2 times 020? Bakit hindi siya kaya?
Sir, kasi po yung third, ano po, zero po yung ano niya. Kahit anong number po na i-multiply is always zero, sir.
Aha. So you're saying imposible na magkaroon ako ng linear combination na hindi zero yung third component?
Sir, try lang po ulit.
Sige lang.
Kasi po kapag in-expand po natin yung equation sa dun po
Aha.
sa values ng 111, ang magiging
Aha.
product niya is 2A, 0 and 0, and 0, 2B, 0, 0,
Aha.
0, and 0, 2B, 0.
Aha. Then I hope I'm doing the math right. I think dito papunta si Leilani. And ito rin yung sinasabi ni si Ian ba yun kanina? Yeah. Na pag in-expand mo yung alpha, yung A yung ginamit ni Leilani, yung A times 200 plus B times 020. So pag inad ko sila, 2A, 2B, 0 yung sagot. And this is what Ian is telling us kanina na hindi pwedeng na magiging laging 0 yung third component ng linear combination, which is correct, right? It is evident here. A and B are real numbers, but the third component remains to be 0. And I think this is what Leilani is trying to point out. Tingnan mo, sir, 1 yung last component niya, imposible na magka-1 kasi laging 0 yung third component nung linear combinations. So I hope it's now clearer na to see ano yung itsura ng mga linear combinations, all right? Okay, thank you guys. That was a nice discussion. Now, ang gusto natin ay hindi lang basta yung ilang mga linear combinations. Ang gagawin ko ngayon, kokolektahin ko lahat ng posibleng linear combinations. So siya yung tatawagin kong curly L of X. So meron ako non-empty, ang dami nating terms. No? Meron ako non-empty subset X of vectors. Kukunin ko lahat ng posibleng linear combination ng mga members ni X. Ilalagay ko siya sa isang set. Ang tawag ko sa set na yun ay curly L of X. Yung curly of L of X, ito yung itsura ng mga laman niya. Lahat ng posibleng linear combination ng mga elements ni X. Okay? Tapos, by convention, mag-agree tayo na ang curly L ng empty set ay zero vector. By the way, minsan abuse of notation ako rito eh. Siguro in the next edition, babaguhin ko yung notations. E is the zero vector. Okay. So, ang set of all linear combinations ng empty set by default ay isa-set natin to be the zero vector, which is the trivial subspace. Okay. So, if you were enticed by yung exchange natin kanina, you can take a look at some exercises here in blue. By the way, yung mga naka-blue box, sila yung mga practice exercises that you can try on your own. And then minsan sa compre exam, dito ako kumukuha sa mga naka-blue. So kung sa akin kayo magko-compre, try as much as possible to answer the ones in the blue. Okay. Yeah. So ilang mga exercises about curly L o yung set of all linear combinations. So you can think about these. Now, theorem number 5. Theorem number 5 contains some results or some facts para sa set of all linear combinations. Okay? So tingnan natin. Ano yung sinasabi? May tatlong bagay na sinasabi si theorem number 5. So, Same thing, si X ay non-empty subset ng vectors. Actually, hindi pala non-empty, ano? Kasi dito si X ay subset na. So si X pwedeng empty, pwedeng non-empty. So si X ay isang subset ng isang vector space V. Kasi nga wala tayong hinihinging property kay X. Subset lang siya. Wala siyang vector space property or whatever. So isa lang siyang arbitrary subset ng isang vector space. At ang mga sumusunod daw na bagay ay totoo. Una, yung curly L of X is a subspace of V. So Theorem 5.1 gives us one way of creating a class of another subspace. So kailangan ko lang palang pumili ng kahit na anong subset ni X, tas kunin ko lahat ng posibleng linear combination ng mga subspace ng mga elements ni X. Yung set of all linear combinations na yon ay isang subspace ni V. So tatlo na yung pwede kong hingin sa inyo na example ng vector space. Ng subspace. Yung vector space itself, the trivial subspace which only contains the zero vector, at saka yung set of all linear combinations ng isang set ng vectors kay V. So that's another example of a subspace. Tapos 5.2 tells us that every subspace of V containing X also contains L of X. So ang sinasabi ng property number 2, kung ito yung vector space mo, tapos diba pag gumagawa tayo ng L, ng curly L, kung pumipili tayo ng set X. Okay. Halimbawa si set X ay napapaloob sa isang vector space. Sa isang subspace. So ito yung ating curly W. Okay. So si capital X, wala siyang vector property, isa lang siyang random subset. Tapos kunwari napapaloob siya kay subspace W. Now sinasabi ng Theorem 5.2, nasa loob din ni subspace W yung subspace of linear combinations. So ayon si L of X. Pag si X ay nasa loob ng isang subspace, yung set of all linear combinations ni X ay nandun din sa loob ng subspace na yun. Okay? Kasi si L of X, parang pinalaki mo lang siya na X. So pero hindi siya lalaki sa isang vector space na nagko-contain kay X. So isang subspace na nagko-contain kay X. And then the last one, L of X is the intersection of all subspaces of V containing X. Right? So siya na yung common sa lahat ng mga subspace na nagko-contain kay capital X. Right? Which sort of brings us full circle to Theorem 5.1. Kasi 'di ba sabi natin kanina sa proposition, I think that was proposition 4, ng intersection ng mga subspaces ay subspace pa rin. So ang sinasabi ng 5.3 ay si L of X, ang intersection ng lahat ng subspace na nagko-contain kay X. Intersection siya ng mga subspaces na naglalaman kay X. So siya ay intersection ng mga subspace. Alam na natin from proposition 4 that the intersection of all subspaces ay subspace din. So this is a subspace of V, which comes full circle with Theorem 5.1. So if you want to go that route, you can just first prove Theorem 5.3, tapos automatic na magfa-follow si Theorem 5.1. Alright? By just invoking proposition 4. Pero hindi yata ganun yung ginawa ko sa module para nag-start ako i-prove sila in chronological order. But you can, again, there's in math, there's always more than one way to kill a cat, so to speak. So bahala kayo kung paano nyo isusulat yung proof. Which reminds me, when I give you the my answers to the homework, huwag kayong masyashock na magkaiba tayo ng sagot. Kasi baka magkakaiba lang tayo ng proof, but parehas tayong tama. So yun yung kagandahan dito. That's why it usually takes me longer to read proofs kasi baka hindi yun yung naiisip kong proof, iba yung atake nyo dun sa proof, and you may be correct. So kailangan ko siyang basahin ng detalyado. Okay? So, ang ibibigay ko lang sa inyo ay yung version ko ng solution. Pero you can draft other versions of the solution. All right? But going back, let's try to prove it. Although there's some complication here, we're talking about L of x. At si L of x may dalawang definition. Si L of x, kapag ka si x ay non-empty, siya yung collection ng lahat ng posibleng linear combinations. Pero kapag ka si x ay empty set, si L of x ay yung trivial subspace lamang, or the subspace that contains only the zero vectors. Kaya kailangan kong hatiin yung proof into two cases. The first case is when x is empty, and the second case is that if x is not empty. So the first part, the one where we assume that x is empty, is quite straightforward kasi ang L of x naman ay trivial subspace. So check na kagad yung theorem 5.1. All right. Ang medyo mas tricky ay yung whenever x is non-empty. All right. But let's see. Okay, case 1. X is empty. So by convention, yung sinabi natin convention or agreement natin kanina, ng set of all linear combinations ng empty set ay the zero vector. Let's keep that in mind. So proposition 5.1 or theorem 5.1 follows easily because we already know that this is a subspace. So this is the trivial subspace of V. So automatic totoo si 5.1. Kasi ang 5.1 sinasabi niya lang si Lx ay subspace. And if X is empty, it turns out to be the trivial subspace. So we're done. The next part is we want to show that what? L of x is contained in any subspace that contains x. So, gusto kong ipakita na si L of x ay nasa loob ng kahit anong subspace na nagko-contain kay x. Pero ano si x natin? Si x ay empty set. At alam natin si empty set ay subset ng kahit na anong subspace. Kaya nag-start ako rito sa pagkuha ng isang subspace ni V at sure ako lagi niyang laman si X. And we want to show that L of X is a subspace of W. Yun yung sinasabi ng theorem 5.2. Na kapag ka si X ay nasa loob ng subspace, yung Lx ay nasa loob din ng subspace. So we want to show that Lx is an element of, or is a subset of the set of is a subset of W, right? Pero ano nga ba si L of x? Si L of x natin ay isa lamang yung laman, which is the empty set. Sorry, not the empty set. Which is the zero vector, right? Ang laman lang ni Lx dahil si x ay empty ay yung zero vector. Tapos si zero vector ay dapat na kay W. Bakit? Kasi si W ay subspace. Alright? Hindi pwedeng maging subspace pag wala sa iyo yung zero vector. So ibig sabihin, yung set containing the zero vector is indeed inside W. And then we're done. Right? Then ano yung pangatlo? Yung pangatlo naman ay kokolektahin mo lahat ng subspace na nagko-contain kay X. Tapos ipapakita natin na yung intersection ng lahat ng mga subspaces na yon ay si Lx. Pero again, madali lang tong gawin kasi si X natin ay empty set. So ang Lx natin is the trivial subspace, right? So una, alam ko na yung zero vector ay nasa lahat ng subspace. Right? So ibig sabihin, yung set containing E ay subset ng intersection ng mga lahat ng subspaces. Kasi si E ay nasa lahat ng mga subspaces. Dahil nasa lahat siya ng subspaces, definitely si E ay nakay intersection. Tinawag ko yung intersection na curly U. So si E ay nakay U. So ibig sabihin, si set containing E ay subset ni U. Okay? Kasi nga, yung zero vector ay nasa lahat ng subspace. Tapos, gusto kong gawin tong equality. So, kailangan kong ipakita na si set containing E ay superset ng intersection to conclude equality, right? Ganun tayo nagpapakita ng equality ng dalawang sets. Dapat ipakita natin na subset yung isang set ng isa and vice versa. That's the only time that they will be equal to each other. So this is quite easy. Kasi nga si E ay nasa lahat ng subspace, So si E ay nasa intersection ng lahat ng mga subspaces. So that's good. Now, paano ko i-argue yung pakabila? Well, si set containing E ay isang subspace. So ibig sabihin, this guy is one of those sets that we intersected to get U. Ano yung nangyayari kapag nag-intersection tayo? Properties of sets. Lumiliit yung set, tama? Lumiliit yung intersection. Kasi halimbawa, meron kang set 1, kunin mo yung intersection with set 2, eto na lang siya, right? Ito na lang yung intersection. Pag nagdagdag ka pa ng isang set, liliit yung intersection. Ito na lang yung intersection natin. Oh. Ito na lang. Right? Pag nagdagdag ka pa ng isang set, mas liliit yung intersection. Ito na lamang yung intersection. Tapos pag naglagay ka ng super liit na set, hindi ko na mapaliit yung drawing, pero pag naglagay ako dyan ng mas maliit na set, nasa na yung intersection? Ang intersection na ay yung pinakamaliit na set, right? Which is that guy. So the intersection of several sets cannot be larger than any of the sets within the intersection, right? Hindi pwedeng mas malaki pa yung intersection sa isa dun sa mga pinag-i-intersect natin. Agree? Kasi ang ginagawa ng intersection, paliit ng paliit yung set habang dumadami ng dumadami yung pinag-i-intersect natin. Kasi yung intersection, set of all elements in common ng mga given sets. Right? So, ibig sabihin, it cannot be larger, the intersection cannot be larger than any one of the sets being intersected. Right? So, ibig sabihin, ang intersection ay laging subset ng lahat ng bawat isang pinag-i-intersect mo na set. So ano yung pinag-i-intersect natin to get U? Pinag-i-intersect natin to get U lahat ng mga subspaces. So that means U being the intersection of all the subspaces of V containing X is a subset of any subspace of V containing X. Yung intersection, mas maliit siya sa lahat ng subspace na nagko-contain kay X. Pero yung set containing the zero vector ay isa siyang subspace ni V na naglalaman sa empty set. So that means one of those we intersect in order to get the set U is in fact the set containing the zero vector. And so the intersection cannot be larger than the set containing the zero vector alone. So U is also a subset of the trivial subspace. Tapos kanina, nasulat na rin natin na si set containing E ay subspace ni U, ay subset ni U. Tapos yung set E ay superset ng set U. So ibig sabihin, si si trivial subspace ay equal kay U. Kasi yung dalawang sets na yan ay subset ng isa't isa. Alright? Which establishes 5.3. Medyo involved yung argument kay 5.3 but I hope it's intuitive. Ano? Okay, good? So don't worry kung medyo may mga fine details, especially if you're not into set theory, pwede na naman siyang balikan later. Go to the recording later or watch some nice YouTube videos about intersections para makita niyo yung mga properties. Tapos pwede niyo siyang balikan whenever you are more comfortable with the underlying concepts behind the argument. But I tried my best to explain yung reasoning behind 5.3. Okay? Yes, Saul, do you have a question?
Yeah, sir. With the explanation that you gave, very clear yung from moreover,
Uh-huh.
parang na-justify nung explanation niyo. Siguro sir, yung question ko, if we're going to prove it now, will this line suffice, or should we have some form of synthesis of how you explained why this is so? Why the
Uh,
line? Holds, opo.
Well, this is fine.
Okay, okay.
So, okay na.
Kayo na po
Okay na yan.
magfi-fill in the blanks, parang gano'n, sir.
Ano na?
Kayo na magfi-fill in the blanks na i-a-assume na namin na gets nyo na,
Yeah.
or
Mhm.
hindi na namin i-explain tong part. Okay, okay. Sige po, sir.
Yeah, yeah.
Thank you
Okay
po.
na yan.
Thank you po. Opo.
Right. Yun yung ano, yun yung isa sa mga challenges pag nagbabasa kasi ng ano, nagbabasa ng kahit sa usual math textbook ano, na parang eto, 2 lines ano, na parang sinasabi na ng book, okay, maniwala ka na kasi yan 2 lines na yan, actually 1 sentence nga lang kasi eto does na eh. So itong 1 sentence na to, pero ang daming nangyayari bago mabuo yung 1 sentence na yun ano, ang haba nung explanation ko bago ako nakarating diyan. Pero this will suffice na, alright? So if you can summarize that 5-minute explanation that I gave for this 1 line, then that's good. Pero yun yung kagandahan kahit ano, kaya actually yun yung maganda sa pagbabasa ng proofs. Even if the proof is already there, you might be tempted to just memorize it, but when you read proofs, merong mga sentences dyan na pwede mong i-expand into several paragraphs. Ano, ang haba ng explanation. But for a practitioner, this would be enough. Pero when you are just beginning to study proving, usually it's nice to write all the details or to take some notes tapos tingnan mo kagad bakit niya sinabi to. So mukhang clear sa kanya, hindi clear sa akin so kailangan kong mag-drawing at kumbinsihin yung sarili ko na okay, kaya niya pala nasabi yung line na yon dahil dun sa explanation na yung set yung intersection hindi pwedeng mas malaki sa isa doon sa mga pinag-i-intersect and so on. All right? But that's good. That's fine. Okay, so let's look at the meteor part of the proof. Ano? Yung case number 2. Sa case number 2 ay ito yung mas involved kasi ngayon si x ay hindi na empty. So yung L of x natin, ito na yung lahat ng linear combination, set of all possible linear combinations. So pag linear combination, siguro sulat ko na lang siya na LC para mas maikse. So meron na tayo ngayong pinagli-linear combination. So hindi na kasing simple nung explanation sa case 1. Okay. Una, gusto nating ipakita na si LX ay subspace. That's theorem 5.1. So siyang ipakita isang subspace. How do I show that something is a subspace? I'm gonna use the compact criterion. Okay? Paano ginagamit si compact criterion? Kumuha ka ng dalawang elements nung gusto mong ipakita na subspace, nung candidate subspace. Ipakita mo na yung sum nilang dalawa ay nasa candidate subspace. Tapos, kumuha ka ng isang scalar, i-multiply mo siya dun sa not just isang scalar pero isang arbitrary scalar, i-multiply mo siya dun sa element ng candidate subspace, pakita mo nandun siya sa candidate subspace. Ganun natin ginagamit yung compact criterion. Alright, so ngayon ang gagawin ko ay so may typo rito. Okay, so here I will get 2 elements of our candidate subspace. Ang candidate subspace natin ay si L of x. Gusto kong ipakita na si V, gusto ko ipakita na si L of x ay subspace. So kukuha ko ng vector V at vector W na parehas na kay L of x. Right? Dahil yung dalawa na yan, so pa-correct naman sa modules, hindi ko pala na-edit yung binigay ko sa inyo, ito dapat ay L of x. Right? Hindi x, dapat siya ay naka L of x. Kasi si L of x, yung gusto kong ipakita na subspace. Okay? Kumuha ko ng dalawang candidate. And again, my goal, I want to show that V plus W is also in L of x as well as alpha V na kay Lx din. Yan yung dalawang bagay na gusto kong ipakita. Okay? Now, preparing for those 2 things that I want to establish, kukunin ko yung expansion ni V at ni W with respect to X. When I say expansion, isusulat ko siya as a linear combination of some members of X. So dahil si V ay na kay L of X, kaya ko siyang isulat as a linear combination ni x1, ni x2, ni x3 hanggang kay xn. Right? Tapos ganun din si W dahil kay L of x din siya, kaya ko siyang isulat as a linear combination ng x1, x2, x3, x4 hanggang xn. Right? Napipili lang ako ng scalars alpha 1, alpha 2 hanggang alpha n and scalars beta 1, beta 2 until beta n. Okay? Good so far? Kinarakterize ko lang ano yung itsura ni V and W being members of L of X. Now sa homework 2, may tanong ako doon. Bakit ko kayang isulat si V at saka si W in this manner? What I'm asking there is, bakit parehas yung, bakit pwede kong i-assume na pwede silang masulat na kasali si X1 hanggang si Xn. Kasi ito, pwede itong, okay, that's fine. Pero bakit hindi ko na lang to ginawang yi? Kasi yung vectors na ginamit ko para i-expand si V ay posibleng iba dun sa vectors na gagamitin ko para sa expansion ni W. Pwede kasing si V, isulat ko as linear combination ng x1 hanggang xn, where all the exabytes are coming from capital X. Pero si W, pwede ko siyang isulat as linear combination ng y1, y2, y3, y4 hanggang yn as long as the yi's are in X. Tapos yung xi dito at saka yung yi dito ay magkaiba. Posibleng magkaiba. Ang tanong ko dun sa homework, bakit pwede kong i-assume na pwede ko silang masulat as a linear combination of the same vectors x1 to xn? Right? So yun yung gusto kong i-explain nyo. Bakit parehas yung mga vectors na ginamit ko pang generate kay V at saka kay W? Bakit sabi ko kaya ko silang isulat as linear combination ni x1 until xn? Or in fact, that is not required for all members of X kasi hindi mo kailangan gamitin lahat ng elements ni X. So posibleng ito, gamitin ko lang si X1, si X2, si X3 hanggang kay X4 halimbawa. Tapos ito, pwedeng si X5, X6, X7, X8 lamang. Pero bakit sinulat ko sila na parehas expansion with respect to X1 until Xn? So yun yung tanong dun sa homework. All right. So if you have some ideas, then choose that. Oh, by the way, you only need to choose 3 out of the 8 problems in homework number 2. So if this is a little bit puzzling for you, then look out for my explanation why we can do that. But yeah, if you have some ideas, then this is an easy 5 points for you. So yeah. Oh, by the way, nabuksan ko na yung submission bin for 2.8. So hopefully you saw it. So kung sinagutan niyo yung 2.8, feel free to upload your submissions to the bin for 2.8 already. Okay? Now, so kaya ko gustong isulat sila in terms of the same exabytes para madali ko silang maa-add. Kasi remember, gusto kong ipakita na closed ang vector addition or closed yung LX under vector addition. So I want to take the sum of V and W. So pag inad ko sila, gagamit lang ako ng paulit-ulit na associativity, commutativity, tapos distributivity ng scalar multiplication over vector addition. Pag inad ko itong dalawa na to, makukuha ko ay V plus W equal yan sa summation ng alpha I plus beta I times x sub I going from 1 to n. Agree? Kasi pwede mong i-factor out yung x sub I by the distributive property of scalar addition. Sorry, not scalar addition, of scalar multiplication over vector addition. So mafa-factor mo yung alpha I plus bi, right? So yun yung nakasulat dito. Medyo may naligaw. Dapat yung n nandito. Yeah. Na-move ko siya sometime when I was making the notes. So yeah, summation ng 1 to n ng alpha I plus plus beta I times x sub I. Right? So after you add the vectors v and w. Alright? Pero anong masasabi niyo rito? Alpha I plus beta I. Yung alpha I plus beta I ay scalar pa rin. Tama? Kasi mga field elements yan. Eh, ang sum ng dalawang field elements ay nandun pa rin sa field. So this is another scalar. So this belongs in the field F. So ibig sabihin si V plus W, pwede nating isulat as a linear combination ng mga exabytes where the scalars are the sum of the scalars used in the expansion of V and W. So indeed, V plus W is also in LX. Linear combination din siya ng x1 hanggang xn, wherein the scalar multipliers are the sum of the scalar multipliers dun sa expansion ni V at saka ni W. Good? So ito yung mahabang explanation if you want to see the pure English of it until dito. Yun yung sinasabi ko dyan. Right? So, we're 50% done. Napakita na natin na si V plus W ay na kay LX. The other half ng compact criterion, tingnan mo yung alpha V. Ipakita mo nandun din siya sa LX. Para si alpha B mag-belong sa LX, dapat si alpha V isulat natin as a linear combination ng mga vectors in X. Right? Pero madali lang siya kasi alam ko si V ay may expansion na ganito yung itsura. Right? So by our assumption that V can be written by as this, since it is a linear combination. Tapos meron akong alpha na multiplier sa labas, copied over. Tapos gagamitin ko lang yung distributivity ng scalar multiplication over vector addition. Remember, this is just the sum of the vectors. And a scalar multiplier can come inside the sum of vectors. So papasok si alpha dun sa summation, so magiging ganito yung itsura. Alpha times the vector alpha I xi, and then we sum them up. Pero associative naman ang scalar multiplication. So instead of multiplying the scalar with the vector, I can group them. I can group the operations such that I multiply the scalars first before multiplying it to xi. That's one crucial property of vector spaces. And only vector spaces alone have that property. Right? Kaya gustong-gusto natin yung vector spaces kasi halos lahat ng magagandang properties ay nasa kanya na. And so now, anong makikita natin? Si alpha V ay pwede kong isulat as ganito. Pero ano tong alpha times alpha I? Si alpha times alpha I ay scalar din. Kasi nga si alpha nanggagaling sa field F, si alpha, lahat ng alpha sabays nanggagaling kay field F, field element times field element is another field element by the closure of the field under scalar multiplication. So this is in fact another scalar. So this is a scalar times a vector. We sum them up. So that means alpha V is also a linear combination of members of X, right? And so alpha V is in LX. And so by the compact criterion, theorem number 3, LX is a subspace of V. Okay? So that's the proof of 5.2. Nakikita nyo na ngayon kung paano nagpa-play or paano tayo nakaka-take advantage dun sa napakagandang properties ng vector spaces at saka mga fields. That's why we insist on working on these algebraic structures. Kasi nandito yung mga properties na kailangan natin. There are some more generic and less restrictive algebraic structures. Kaya lang pagka binawasan kasi natin yung properties ng fields, at binawasan kunwari natin yung properties ng vector spaces, so meron tayong mas loose na algebraic structure, hindi natin mapuprove lahat ng mga properties or hindi mag-hold lahat ng mga properties na meron tayo dito. Okay, now let's move to theorem 5.3. Ang gusto naman nating ipakita, hindi pa pala, 5.2 pa lang pala tayo. So na-prove natin yung 5.1 na si L of X ay subspace. Right. The second theorem tells us that what? Si LX ay nasa loob ng kahit anong subspace na nagko-contain kay capital X. Alright? So in diagrams again, meron kang vector space V. Tapos halimbawa si X na ginamit natin to generate LX ay kunwari nandyan. Kunwari siya ay napapaloob sa isang subspace W. Okay? Now, yung LX ay mas malaki kay X. Kasi kinukuha natin lahat ng posibleng linear combination. Pag tinake mo na lahat ay 0 except for 1, makukuha mo yung elements ni X. So, lumalaki yung set kapag kinukuha mo yung LX. Alright? Pero sinasabi ng Theorem 5.2, hindi siya lalaki sa kahit anong vector space na nagko-contain kay W. So, X will be enlarged to LX but not large enough to go out of W. So yung LX natin, dapat ganito lang yung magiging itsura. So ito si LX. Nasa loob pa rin siya nung W. Yun yung gusto ko ipakita. Yun yung sinasabi ng Theorem 5.2, which is what we want to show in this proof. Okay? So again, ang gagawin ko, ang strategy ko ngayon, gusto kong ipakita, so we want to show yung WTS ay we want to show, yung ginagamit kong abbreviation. So we want to show that L of X is a subset of W. For every W that contains X. So kapag kalaman ng isang subspace W si X, automatic laman niya rin yung lahat ng linear combinations ng members ni X. So to show this, essentially sa set theory, ito lang yung gusto kong ipakita. So what I'll do, the strategy is, I'll get an element of LX and show that it is also in W. Yan yung gusto kong ipakita. Yan yung paraan ng pagpo-prove ng 5.2. Kumuha ka ng isang arbitrary element ni LX, pakita mo na yung element na yon, I called it little v, ay nakay curly W. Okay? So yun yung try natin gawin sa proof ng theorem 5.2. Okay. So si W, inassume ko lang na subspace ni V na naglalaman kay X, na superset ni capital X. So ngayon, sinisimula ko na yung gusto kong approach dun sa proof, I am taking a V in LX. Dahil si V ay na kay LX, again, eyes on the ball. Gusto kong ipakita na si V ay na kay W din. So what I will do is look at the properties or take advantage of the properties of V being in LX and show that it is also in W. Okay? So dahil si V ay na kay LX, kaya ko siyang isulat as a linear combination of some members of X. So si V, kaya kong ma-expand as summation ng alpha i's that are scalars times vectors x sub i's coming from capital X. Okay? Now, gusto ko itong ipakita ay na kay W. Bakit siya mapupunta kay W? Well, let's see. Ano ba yung building blocks ni V? Now, si V, meron siyang mga xi. Si xi's ay nanggagaling kay x. Right? Pero, si x ay subset ni W. So, lahat ng mga x sub i's na nakay x ay nakay W din. Agree? Kasi dito sa Venn diagram natin, si x1 nandito, si x2 nandyan, si x3 nandyan, si x4 nandyan, si xn nandyan. Right? Lahat sila ay nasa loob ni X, so therefore nasa loob din sila ni W. Kasi si W ay superset ni X. So that means these guys are all in W. Right? Nakay W silang lahat. Tapos si alpha I ay scalar. So meron akong scalar times element ni W. So that means this product is also in W. Why? Because W is a subspace. And a subspace is always closed under scalar multiplication. So pag nag-multiply ako ng isang scalar sa isang element ng subspace, yung sagot nandun pa rin sa subspace. Eh si xi, hindi lamang siya na kay x. Na kay x nga siya, pero nga na kay w din siya, na subspace. So ito ay nasa subspace w. Alright? Eh sinum ko ngayon. So yung alpha 1 x1 na kay w, i-add ko siya kay alpha 2 x2 na kay w din, Tapos yung sagot, i-add ko sa alpha 3 times x3 na na kay W din kasi nga vector space yan. So ano masasabi ko sa entire sum? Yung entire sum na yan ay dapat na kay W din. Bakit? Closed ang vector addition, closed ang isang subspace under vector addition. Pag nag-add ka ng mga vectors na nasa loob ng isang subspace, ang sagot nandun pa rin sa subspace. Alpha 1 x1 is in W, a subspace. Alpha 2 x2 is in W, a subspace. Alpha 3 x3 is in W, a subspace, and so on. So pag nag-add ako ng mga elements ni W, yung sagot na kay W pa rin. So that means V, which is this summation over here, is also in W, right? Which fulfills our goal na ipakita na si V ay na kay W. So si V ay na kay W, so therefore si LX ay subset ng kahit na anong subspace W that contains X. Okay? Right, is that good? All right, thank you. Okay, last. Gusto kong ipakita ngayon na si LX ay ang intersection ng lahat ng subspace W containing X. Okay? Now, so si LX dapat siya ay intersection ng lahat ng subspaces. Tawagin ko yung intersection na yun na curly U. So si curly U, siya yung intersection ng lahat ng subspace ni V na nagko-contain kay X. Dahil si LX, ito yung nasa moreover kanina na tinanong ni Sol dun sa case number 1. Si LX ay isa dun sa mga pinag-i-intersect ko. So ibig sabihin si curly U ay hindi pwedeng maging mas malaki kay LX kasi si LX isa dun sa mga pinag-i-intersect. So U could be at most LX. It cannot be larger than LX. So we can easily say that U is a subset of LX. Okay. Pero ang gusto ko ipakita na si LX ay equal sa intersection, so I need to argue yung pakabila. Okay. Pero madali lang yung pakabila kasi ang gusto ko ipakita dun sa pakabila, si LX ay subset ni U. Okay. But U is the intersection of all subspaces of V containing X. Intersection siya ng lahat ng subspace na nagko-contain kay X. So ibig sabihin si U itself is a subspace containing X. Kasi from what? Proposition 4, ang intersection ng mga subspaces ay subspace din. So U being the intersection of subspaces ay isa ring subspace on its own. And more than that, it is a subspace containing X. Right? So that means by proposition 5.2, dahil kinocontain ni U si X, dapat kinocontain din ni U si L of X, which is this guy. Na napakahaba nung sinabi ko, pero nung sinulat ko siya, sinabi ko lang siya from bullet 2, LX is a subset of U. But again, the explanation there is that U is the intersection of all subspaces of V containing X. So itself, it is a subspace of V containing X. Therefore, it will contain LX by theorem 5.2, right? And since we have the two subset relations over here, U and LX are subsets of each other, so therefore LX is equal to U. And that completes the proof. Okay? Now, some terminologies, probably gusto ko sanang simulan yung module number 3, pero feeling ko pagod na kayo. Too much information na ba? Na-feel ko na rin ng konti yung pagod. Ano? Parang mas optimal na 1.5 hours lang talaga. No? Parang hirap ng 2 hours. Pero I remember last mid-year, ginagawa namin 3 hours. So talagang pagod kami. So yeah, maybe we can stop here. I'll just introduce a couple of terms, and then we can revisit and augment them with some examples from module number 2. Okay? All right. Now, hindi pa pala kasi meron pala akong mga examples pa rito. But I think these are examples na lang, so madali natin siyang madadaanan. But a terminology first, si LX, this is called the subspace generated by X. So yung LX, set of all linear combination of X, dahil sure na tayo na siya isang subspace, we can crown it as the subspace generated by capital X. So parang siya yung subspace na nabubuo ng isang non-empty set X. Right? Kasi nga si set X, wala siyang vector space property. Pero kaya mo maka-generate ng isang subspace mula kay capital X by taking all possible linear combinations of members of X. Then the set X is also called the generating set or the spanning set for LX. So nagja-generate ng LX ay si X. Okay? Some quick examples. Etong vector, etong set X na to, 1, 0, 0, 0, 1, 0, 0, 0, 1, siya ay generating set ng vector space F3 over F. Here, I'm talking in a generic sense, where F is any field. So, and then 1 here is the unity in the field, not necessarily the number 1. Pero kahit ano pang field yan, kunin mo lang yung multiplicative identity mo, tapos ilagay mo lang siya sa tatlong dun sa magkakaibang posisyon dito sa vectors mo. Kung F3 ka, so meron kang tatlong components, lagyan mo lang bawat isang component ng 1, tapos i-zero mo na lahat ng ibang component, then you get the vector X. And the vectors and the set X here, is a generating set for the vector space F3. Okay? So if you want to contextualize it, well, kung na kay R3 ka, kung ito yung vector space mo, so ibig sabihin, this is the number 1 talaga, this is the number 1 talaga, this is the number 1 talaga. The multiplicative identity in R is 1. So kinuha ko lang sila, tapos dahil may 3 possible components ako sa bawat isang vector, kasi na kay R3 nga ako, ang gagawin ko, magagawa ko na isang vector na yung first component ay 1, tas 0 na siya sa lahat. Then another vector, 1 yung second component, and then 0 palagi yung natitira. And then the last one, I'll create a vector whose third component is 1 and the rest are zeros. Then this set, so constructed, will give us a generating set for the entire vector space R3. So what's the meaning of being a generating set for the entire vector space F3 or R3? That means any vector in the vector space can be written as a vector space, as a linear combination of members of X. In other words, L of X here ay equal kay F3. Or in the case of the real numbers, Lx is the entire R3. So we say that R3 is generated by the set X, or the set X is the generating set for R3. Okay? Now, that's usually the case if you want to get a generating set for the entire vector space, wherein your vector space is coming from a field. Pwede ka mag-construct ng ganitong vector. So yung naglalagay ka nga lang ng unity, tapos 0 na elsewhere. Unity sa bawat isang possible component, tapos 0 na elsewhere. And there's a special term for this. This is what we call the elementary vectors. Mga elementary vectors sila kapag ka isa lamang yung non-zero entry nila. At yung non-zero entry na yon ay yung unity ng field o yung multiplicative identity dun sa field. Yun yung mga elementary vectors natin. And the set of all elementary vectors is a generating set for the entire vector space. Okay? All right, is that good? So ito yung tinatawag natin na ito yung paborito nating mga unit vectors, ano? So kung nagtuturo kayo ng elementary algebra or sa physics or saan pa nga ba ito ginagamit? So kahit sa calculus, ano, so ito yung tinatawag natin na unit vectors. Pero hindi lang kasi sila yung unit vectors. Kahit anong vector na ang length ay 1 ay unit vector. So rightfully, these are the unit elementary vectors or simply the elementary vectors. Okay. Ginagamit siya, mahalaga siya kasi na-generate niya yung entire vector space. Now, a non-example is this set Y, 100, 010, and 110. This will generate a vector space. Pwede mong kunin lahat ng set, yung set ng lahat ng linear combinations ng elements ni Y, pero hindi siya yung buong F3. Hindi siya generator para sa buong F3. Kasi merong mga elements ni F3 na hindi kayang masulat as a linear combination of Y. There's another typo. Dapat may end brace doon. Right? Hindi siya generating set ni R3 kasi nakakuha ko ng isang vector na na kay F3 pero wala kay LY. Right? Base 001. Si 001 ay hindi linear combination ng members ni Y kasi kung mapapansin nyo katulad nung napag-usapan natin kanina, tingnan nyo yung tatlong huling components ng mga vectors kay Y puro 0. So we can expect that Ly will consist at most of vectors with zero third components. Pero yung 001, non-zero yung third component niya, imposible siyang masulat as a linear combination of members of Y, but 001 is in F3. So we can say that although Ly will generate a subspace of F3, hindi niya kayang ma-generate yung buong F3. Okay? Now, a special kind of set of linear combinations. I just need to say this because I think this is part of the problems in the homework, if I am not mistaken. So yung affine combination naman. So yung affine combination, isa siyang special na linear combination. O mga special linear combination sila. Remember, yung linear combination, kailangan mo lang masulat ang isang vector as the sum of scalars times vector. Wala tayong restriction sa mga scalars. Kahit anong scalar, pwede mo magamit. Pero if you're looking at an affine combination siya kung isa siyang linear combination, pero yung sum ng mga scalars ay equal kay 1. Okay? So dapat nag-equal kay 1 yung mga scalars. So halimbawa kay R3, halimbawa meron akong vector space V over R, kunwari, right? So ang field ko ay R. So yung 1/2 x1 plus 1/2 x2, this is an affine combination. Kasi pag kinuha ko yung scalar 1 at saka yung scalar 2, ang sum nila ay 1. So it is an affine combination. Yung x1 plus x2 is not an affine combination. Kasi ang multiplier mo dito ay 1, ang multiplier mo dito ay 1, 1 plus 1 is 2, not equal to 1. So therefore, that's not an affine combination. Kailangan sa affine combination, equal kay 1 yung sum ng mga weights o ng mga scalars. So, but there could be several combinations to it. I can have 2x1 minus 1x2. This is an affine combination because when you take the sum of the scalars, you get 2 plus -1. That will be 1. So that's an affine combination, right? And this is of interest if you're doing optimization. All right. So if you're into applied math, you're doing optimization. Some of the objective functions that you will be dealing with are affine combinations. Kaya medyo mahalaga yung affine combinations. So we denote the set of all affine combinations of x to be script A of x or curly A of x. All right. So ito yung affine set of all affine combinations, which we also call the affine hull. So ang affine hull ni X ay nilalaman lamang lahat ng affine combinations ng mga members ni X. Okay? Then you can think about 11 and 12. We will skip proposition 6, exchange property. This is a nice property, but this is scarcely used in analysis, but it's just there just in case we will need it. Pero I think we can skip proposition 6 to medyo streamline the process. Okay, and then what else? Yeah, last few terms. Malalobat na rin yung, yung laptop ko. But anyway, So we say that the vector space V is finitely generated if it has a finite generating set. Okay? So halimbawa, si R3, yung mga three vectors, ano? Nakita na natin kanina na si 1, 0, 0, yung elementary vectors, 0, 1, 0, at saka si 0, 0, 1, is a generating set for the entire R3. So ibig sabihin, we have found a finite generating set, a set X consisting only of three members that can generate the entire vector space R3. So that's why we can say that R3 is finitely generated because it can be generated by a finite set as a linear combination. Okay, so finitely generated. Now, being finitely generated doesn't mean that the set is finite. So yung vector space natin na R3, infinitely many yung laman niya, right? Infinitely many ang mga three vectors, right? Ang mga vectors with three components in R. Now, finitely generated siya. Tatlong elements lang yung kailangan mo para ma-generate yung buong R3 in terms of linear combinations, kahit infinitely many yung laman niya. Okay. And this will play a crucial role when we are studying vector spaces that has a humongous number of elements, katulad ng R3. Infinitely many yung laman ni R3. So if you want to study how functions behave from R3 to R3, which is the goal of linear algebra, no? Gusto natin yung functions from a vector space to another vector space. Mahirapan tayo kung pag-aaralan natin yung action ng mga functions na yon sa lahat ng vectors. Kasi usually ang mga vectors na gusto natin ay infinitely many yung laman. Now, the next module will give us a nice insight on how to deduce that problem of studying all vectors to studying just a small portion of the vector space. Makikita natin sino lang pala yung mga vectors na dapat kong pag-aralan para malaman ko na yung property ng buong vector space. Because again, we cannot study all the vectors in a vector space because those vector spaces of interest to us are infinite. Ang dami nilang laman. So we cannot afford to study all of the vectors. But the next module will tell us there are select members of the vector space that we ought to study in order to get the property of the entire vector space. And that the finite generators of a vector space will be crucial to that. So katulad nung kanina, spoiler alert, kung gusto kong pag-aralan paano nagbe-behave ang mga vectors sa R3, hindi ko kailangan pag-aralan lahat ng vectors sa R3. Kailangan ko lang pag-aralan paano nagbe-behave yung elementary vector 0, 1, 1, 0, 0, 0, 1, 0, at saka 0, 0, 1. Instead of studying infinitely many vectors, I need to study only 3 under transformations. All right? Yun yung kagandahan dito sa titingnan natin sa linear algebra. And we will study next time in module number 2 kung sino-sino or paano ko pipiliin sino-sino yung mga pag-aaralan. And spoiler alert, kailangan nating pag-aralan yung mga basis elements. The next question we will answer when we meet next time is ano yung basis? Ano yung mga basis elements? Or ano yung mga bases? Ilan ba yung bases? Ano yung mga property ng mga bases ng isang vector space? All right. So I guess there's still couple more pages here and some more examples, right? But I think you can read them on your own. They are self-explanatory. If there's something not clear about the last few examples in this module, examples 12 until 16, let me know by Wednesday. So we'll meet again on Wednesday, but probably I'll start with asking you questions about the module, the rest of the module, but I will start with module number 2 right away. Okay. So with that, I think this is a good place to stop. Unless you have some questions, burning concerns. Wala na po ba? So I'll be waiting for the rest of your submissions to homework 2 on Monday, And then I'll start grading na tomorrow. Pero medyo sana mas madali na kay Moodle yung pag-check. But otherwise, I'll need to download everything, load them on my tablet, and then mag-upload ako isa-isa. So hindi magiging real time kasi sa ibang LMS kasi real time pag nag-annotate ako dun sa kanyang submission through the app, nakikita na nung student yung mga pinagsusulat ko right away. So maybe you might need to wait for until Monday to get the first batch of feedback from me. But and then also I'll try by Monday to give you the my solutions to the problems in homework 1 and then homework 2 probably with the middle of next week. All right? So I think that's it. So there are no if there are no other questions or concerns, so thank you guys for joining me on this Saturday evening. I hope you get some rest kahit sinisira ko yung weekend nyo. Hindi kasi ako pwede yung Friday, sorry guys. And then I think gabi lang tayo pwede man ng Friday, but I'm not free every Friday. But thank you for bearing with me and agreeing to meet on a Saturday. So enjoy the rest of the weekend, stay safe, and let's see each other again on Wednesday, all right? Bye, guys.
Thank you,
Thank you,
sir.
sir. Bye-bye.
All right. Bye.